All right, let's dive into one of the coolest parts of modern AI, unsupervised learning. It's basically the art of teaching a machine how to find hidden patterns all by itself, with zero instructions from us.
So, picture this. Someone hands you a massive library, but all the books are just thrown into one giant pile. No titles, no genres, nothing. How in the world would you even start to organize it? Well, that's pretty much the exact problem that unsupervised learning is built to solve.
To really get why this is such a big deal, we have to start with the world as our machines actually see it. And that world, it's almost completely, fundamentally unlabeled.
I mean, think about it. Every single photo you take, every online purchase, every little piece of data from a sensor, most of it is just raw information. It doesn't come with neat little tags saying, hey, this is a cat, or watch out, this is a fraudulent transaction. It's just this enormous sea of data, and trying to find any value in it is a huge, huge challenge.
And that's exactly where unsupervised learning comes in. It's a whole set of techniques that lets an algorithm become a kind of explorer. So, instead of being told what to look for, it just dives into that chaotic sea of data and starts drawing its own map, finding its own little islands of meaning. So what's the core mission for this digital explorer? Well, it's not about finding one specific right answer, like it's taking a test. It's about something way deeper. It's about understanding the very structure of the data itself. The very first step is what we call data exploration. Seriously, it's just like an explorer setting foot on a new continent for the first time. They're not looking for a specific city. They're trying to map the rivers, the mountains, the coastlines, just to understand the shape of this new world. And this gets at a really profound idea. Unsupervised learning isn't just sorting stuff. The goal is what our source calls epistemic reconstruction. Now, epistemic is just a fancy word related to knowledge itself. So what this means is the machine is literally rebuilding our understanding from the ground up, finding the secret order that's hiding inside what looks like total chaos.
Okay, so how does this digital explorer actually pull off this magic trick? What's in its toolkit? Let's break down the 3 essential tools it uses for discovery.
We can really think of these tools in pretty simple terms. First, you've got to be able to group similar things together. Second, you need a way to simplify a really complex map. And third, you need the skill to spot something that just doesn't belong.
So our first tool is clustering. This is basically the algorithm's way of finding natural communities. Back to our library mess, this would be like grouping books based on the language they're written in, or maybe how thick they are, or even the texture of the paper, all without reading a single word. It just finds what's similar and puts it together.
And what's so brilliant about some of these methods, like hierarchical clustering, is how flexible they are. See, with other methods, you have to tell the machine, hey, go find me exactly 5 groups. But this technique, it doesn't need the answer ahead of time. It just explores the data and shows you all the possible groupings at different levels. It's perfect for genuine discovery. Next up is Dimensionality Reduction. I know, it sounds super technical, but the idea is actually pretty simple. Imagine trying to understand your customers by tracking 100 different things about them. It's impossible for a human brain. This tool finds the 2 or 3 key factors, the most important things, like how often they buy and how much they spend, that actually explain most of what's going on. It just simplifies the map down to what truly matters. And that's the absolute key right there. We're taking this incredible, overwhelming complexity, this cloud of hundreds of data points, and we're boiling it down to its most essential coordinates. We're finding the fundamental axes that actually define the whole system. And finally, our third tool, Anomaly Detection. Okay, so after our explorer has mapped the landscape and figured out what's normal, this is the ability to spot the oddball. It's that skill of noticing one weird signal, that one data point that just doesn't fit the pattern of everything else. And trust me, this isn't just a party trick. Finding the outlier is absolutely critical in the real world. This is how your bank spots a strange transaction on your credit card. It's how security systems detect a potential hacker. And it's how engineers can sometimes predict a catastrophic failure in a jet engine before it even happens. So, our explorer has returned from their journey, they've used all their tools, but what was the point? The final amazing reward is turning all that abstract discovery into something we can actually understand and use. The first part of that reward is the map itself, visualization. This is how the algorithm shows us the world it discovered. There are these really advanced techniques, like something called a T-SNE plot, that are designed to do just this. They can take that hopelessly complex data and flatten it into a simple 2D map where we can literally see the clusters and relationships the machine found.
And this brings us to the ultimate treasure, the thing our explorer was after all along, what the source calls data yield. Really, it's just a simple word: insight. This is the real prize. It's not just finding a pattern, it's the knowledge we can actually use that we get from that pattern. It's that aha moment when raw data becomes a brilliant business strategy or a brand new scientific theory.
So let's just put it all together. The journey of unsupervised learning is this incredible transformation. It takes that giant, messy pile of information we started with, and, with no human guidance at all, it finds the hidden structure and turns it into organized, actionable knowledge. It literally creates order from chaos.
And this leaves us with a pretty mind-bending question, doesn't it? If these algorithms can already sift through all this noise and find patterns that are totally invisible to the human eye, and they're doing it in everything from stock market data to medical scans, what other incredible secrets are just hiding there in plain sight, waiting for the right explorer to come along and find them?